5.2, we're going to talk about linear growth in math. So we're going to get into slope and writing equations of lines and all of that stuff that we did in Algebra 1 and 2. But just to start, we're going to talk about growth. So the relationship between quantities that vary at the same rate or that vary with each other, those are known as proportional. And those can always be written as linear functions, and typically we're going to write those as direct variation functions. So if two things are proportional, there's a direct variation between them. We're going to see an example of this in a second, and what it means is it's essentially going to be an equation with a slope and then a y-intercept of 0. So as something increases, something else also increases, or maybe as something increases, something might decrease. So an easy example to show what this is here. So Jessica is interested in purchasing a new video game, and that costs $60. If she has a job that pays $7.50 per hour, find a linear equation for her income and determine the number of hours she must work in order to have enough money to buy the game. Now in practice, a lot of times we just end up solving this in our brain or with a calculator by saying, hey, we're making $7.50 an hour, we need $60, how many hours? Well, we just take 60 divided by 750. And that's totally right. But if we want to write an equation, so we could change this if need be, if we want to do income versus hours, you could say her income is determined by the number of hours worked, because every hour she makes $7.50. So you could do 7.50 times the number of hours she works, or just 750h. So now when we have a goal in mind of 60, this is where our solving comes into play, because we know 60 is equal to 7.5h, and then we can divide both sides by 7.5, and we would get our answer of 8 hours. So that's direct variation on its most simple level. It's always of the form y equals like mx, where there's no b, because b is just 0. Like in this case, you don't have a starting amount for Jessica. You're just told that every hour she makes so much money. So that's direct variation. Here would be the graph of any direct variation equation. This is actually the graph of our last equation. So y equals 7.5x. We did I equals 7.5h. But the idea here is as hours increase, her payment amount would also increase by that same steady 7.5 per hour until we work 8 hours for that $60. So let's try another one. If you want to pause the video and try it on your own, feel free. But if Andrew earns $6.75 for every dozen oysters that he catches, how many dozen oysters must he collect to accumulate $215? So first we're going to write a linear equation for this. So we're going to do it very, very similar to the last one. We can do income equals 6.75 x or h, whatever you want to do, but this is dozen oysters. So maybe we just say x, where x is a dozen oysters. I here is just our income. So then when we want to solve, we would have 215 is equal to 6.75x. And then I'm going to need to take out my calculator 1 second. 215 divided by 6.75, we get 31.85. So he's getting paid by the dozen, so we would need to round this up at 32 dozen. He's not going to be able to turn in 0.85 dozen oysters. I'm sure he's selling them in dozens. All right, so all of this ties in with slope. So the last two problems we did, that dollar that we made per hour, that was just our slope. So as you recall from your algebra classes, slope, we use the letter m, and that's just describing the rise over the run, or maybe more specifically, how does one value change as the other value changes? So the change in y values over the change in x values is your slope. If you're given 2 points, x1, y1, and x2, y2, the slope equation is here. You've been doing this since 8th, 9th grade. You can just plug in values to find slope or to find your rate of change. The graph of a function that makes a line with a constant rate of change, that's just a linear function, or just a straight line. So not a parabola or anything like that. It's just a straight line going up or down. The x and y intercepts are the point where the graph crosses the x and the y axis. So if I draw a line like this, my x-intercept is right here. My y-intercept is where I'm crossing the y-axis here. I know these are things that we do know, just a friendly reminder for this video. Slope-intercept form is our most commonly used form of a line in math class. Y equals mx plus b. M is your slope, b is your y-intercept. So if you wanted to graph this line, you would start with a y-intercept of 4. We're just doing a sketch. And then our slope of 2 means we're going up 2 for every 1 unit we're going over. Look something like that. So our third example here, assume Jeffrey has an uncle that puts away $10 in a shoebox on the day he's born, and then adds $5 to that shoebox on his birthday every year. If this trend continues, use a linear equation to find the amount of money in the shoebox on Jeffrey's 18th birthday. So you can make a table to describe this, but we can also write an equation. So to write an equation, we have to figure out what our m value is, what our b value is. So let's talk about what those mean. Our m value is what we're going up by for, in this case, each year. So in this case, that would be 5. Our b value is our starting amount. So this is where you're starting at day 0, or in this case, year 0. That would be your b value, so that's plus 10. So that's our function. So if we want to find the amount of money in the shoebox on the 18th birthday, we just plug 18 in for x. So y is 90 plus 10. So y is $100. So you have a nice uncle, going to give you $100 on the 18th birthday. Probably not the wisest investment decision to put money in a shoebox, but we can talk about that a different day. Here's a graph of that. You can see we're starting at 10, and then for every year, we're going up $5 more. Last one we're going to look at today. Cindy's starting a business selling t-shirts. Each shirt costs $9. There's an artwork fee of $12.75 per order. Find a linear function that could be used to represent the cost of each t-shirt order. So if you want, go ahead and pause this video right now and then try this on your own and see how you did. Okay, so in this case, we have y equals mx plus b. We got to figure out what's our starting amount and what's our slope. So in our case here, our starting amount's pretty easy to see. We're going to have $12.75, a flat fee per order. And then we're increasing $9 per t-shirt, so that's our slope. So y equals 9x plus $12.75 would be your final answer. And that wraps us up for 5.2. Basically just a big refresher of linear things from your Algebra 1 and Algebra 2 classes.